Alright, so Unit 4 is all about a kind of a new type of function that we haven't talked about yet, and those are called quadratic equations. So there's four questions I want to answer for you in this video and the next. First of all, what is a quadratic function? And most of what we've been studying so far were things like linear functions. So here's the classic example, y equals mx plus b. That's called slope-intercept form. What makes this a linear function is that x is being raised to the first power right there. So linear means x to the first power. A quadratic function, we'll answer questions 1 and 2 right now. What is it? What does it look like? It looks like this. Quadratic function looks like y equals a number times x, and now x is being raised to the second power. Okay, and then we have some other terms here. X is being raised to the first, and then a, b, and c in this case just stand for numbers. So for example, this would be a quadratic equation right here. 3x squared plus 4x plus 1, let's say. The a value is the number in front of x squared, so a in this case would be 3. The b value is the thing that's in front of the number that's in front of x, the coefficient I should say, and then finally c is the thing that doesn't have any x next to it. And the name for that, by the way, that's called a constant. Constant means it has no variables. So the biggest difference between a linear function like this one and a quadratic function like this one is that in a quadratic function, x is being raised to the second power. That's what we mean by a quadratic function. Okay, the other thing I want to answer is, what does it look like when we're talking about how to graph? What does the graph look like? The graph of a quadratic function looks roughly like this. Okay, it's called, the name for that, it's kind of a U shape, and the name for that is called a parabola. Okay, parabola or U-shaped graph. This graph that I just drew right here is the graph of y equals x squared, and we call that the parent graph because all other quadratic functions are going to look exactly like this one. They're going to look somehow like a U shape. They might be shifted somewhere, so we could have a graph down there. We could have a graph that's upside down, but you can see that that blue one, that green one, they all somehow look like this function right here, this parent function, which is the red U shape. Okay, question 3 says, how do we put something in standard form? This right here, the way that I wrote that, that is considered standard form. The way that you write an equation for a quadratic equation is that it's a number times x squared plus a number times x plus a constant term plus c. So for example, this right here is in standard form, and usually it's equal to either y, or when we're solving equations it will be equal to 0. Okay, question 4 is what we want to look at right now, and that's how do you sketch the graph for one of these. So that's what we'll get into. Okay, and there's a kind of like a 4 or 5 step process which is written right here, and the key step is this one right here. Step number 1, the very first thing we want to do is we want to find the vertex. Okay, the vertex on the graph is where I'm putting that blue dot right there. Okay, or let me show you the other vertex. So this right here, where that pink dot is, that's the vertex. That's the vertex. The vertex is basically the bottom point of the U, or in the case of the blue graph right here, it would be the top point. So if you can find the vertex, it's usually easy to get the rest of the graph. Okay, how do you find the vertex? Because that's the first thing we need to do. For now, just take my word for it. Later in this unit, you'll understand why this is true, but for now, just take my word for it. The way that you find the vertex is, at least to find the x-coordinate, you take negative b over 2a. Okay, that's the x-coordinate of the vertex. What does that mean? Remember that we said quadratic equations are in standard form when they look like this. A number times x squared plus a number b times x plus a number c. This right here, number 1, is in standard form because the number in front of x is 1, so that means a equals 1. The number in front of, sorry, that I meant to say x squared, the number in front of x is 4, and this constant term by itself is 3. So if we want to find the vertex, this is the formula that we use. We basically take our b value, which is 4, and we plug it in. So let's do that right now. The vertex for the x-coordinate is going to occur at negative b over 2a. b in this case we already said is 4, so negative b will be negative 4 over 2 times a. So that means 2 times a is 1 right here, so 2 times 1. So negative 4 over 2 times 1, that would be 2. Negative 4 over 2 is negative 2. This right here is the x-coordinate at the vertex. Okay, that is the x-coordinate at the vertex of our parabola. So how do we do the rest of it? Okay, I'm going to skip around with these steps a little bit. The rest of this, we found the vertex, at least for the x. How do we find the y-coordinate? Okay, because a vertex is supposed to be a point. It's supposed to be an xy point. To find y, we just plug in our x value that we just found. Okay, and the question is, where do we plug it in? We plug it into this equation right here, because y equals all those things with x in it. So y is going to equal x squared, but again, we just found that x is -2. So -2 squared plus 4 times x. Again, I'm getting that from right here. 4 times x, that means 4 times -2 plus 3. -2 squared, -2 times -2 is 4. 4 times -2 is -8. And then we have plus 3. 4 plus -8 is -4, and -4 plus 3 is -1. So that is the y coordinate that we just found of the vertex. Okay, so let's get our first step here out of the way. So the vertex that we just found is x equals -2, y equals -1. X equals -2, y equals -1. So let's plot that on the graph. There's the point. X equals -2, y equals, sorry, that's not the point, -1, it's the point +1. So -1 should go down below that. Let me just erase this. Okay, so -2, -1 is right here. Okay, the other thing is, notice on the last page I showed you a couple pictures of those U shapes of those parabolas. And the question is, when sometimes they open up, sometimes they open down. How do you tell the difference? The answer is by looking at this number right here. If the a value is positive, that means if it's greater than 0, it's going to open up. And if the a value is negative, meaning it's less than 0, it's going to open down. So in this case, a equals +1. So this parabola, if we draw it correctly, it should open up. Okay, this looks a little bit imposing because there's all these steps right here. So I'm just going to clear off some space so we have more room to work here. This looks imposing with these 5 things that you got to find, but actually what's nice is once you find the vertex, you pretty much have almost half this problem done already. So we just found the vertex. Okay, so we'll check that off. We found the vertex right here. That's good. Okay, what else have we just found? Well, the axis of symmetry is basically this. If you have a parabola, okay, there's our U shape. The axis of symmetry is this line right here. And when we say that something is symmetric, it basically means you can like fold it right on top of itself. So if you were to take that parabola and split it right where that red line is, it would be kind of a perfect image of itself. You could fold it neatly right on top of another. If you took that and just kind of folded it, it would match perfectly. So that red line right there, that vertical line, that's what we mean by the axis of symmetry. It's a line that cuts through the parabola that makes it symmetrical. Okay, why did I say it's easy to find it? Because the axis of symmetry is actually this number right here. Whatever the x coordinate is, and I'll show you on the graph. So this blue line right here that I'm drawing, okay, that right there is the axis of symmetry. What's the equation of that blue line? It's x equals -2, which is what we found for the vertex. Okay, we also found the max or min value, so that's number 4. The max or min value always occurs at the vertex. Okay, we know that this parabola right here is going to open up. And just to emphasize, how do we know that? Because this a value right here is positive. That's a 1, and 1 is a positive number. We know it opens up. So just like this parabola, if a parabola opens up, then this point right here, if you look at it, think about it, is that going to be a maximum or a minimum? And the answer is that's going to be a minimum point. That's the lowest possible point on this graph. This parabola actually doesn't have a maximum because these arrows point upwards forever. So it never actually reaches a top point. It just keeps going. So in this case, we found that the minimum value is going to be this number right here. Y equals, that's a -1 right there. So y equals -1 is the min. So the reason I said finding the vertex is so important, because if you find the vertex, you automatically know the axis of symmetry. It's the x value right there. And you automatically know the max or the min. It's the y value right there. Okay, now let's work on sketching the graph. And the way to do this is just make a table of values. And in order to get a good parabola, you really only need 3 points. And one of them we already found. One of them we found was the vertex at -2, -1. Okay, in order to make this, remember we said parabolas are symmetrical, so what's nice, a little bit of a shortcut for us, to make this work, I'm going to pick one x value that's less than -2, so let's go with -3. I'm going to go one x value that's more, let's call it -1. Okay, here's the thing to notice, I'm going up by 1 each time, and in order to get this trick that I'm about to show you to work, you have to make sure that the distance is the same each time. How can we find the y value? We can just plug it in, so -3 squared plus 4 times -3 plus 3. Move this out of the way. So negative 3 squared is going to be positive 9. And then 4 times negative 3 will be negative 12. Excuse me, I'm just trying to clear off some space there. So that's 9 plus negative 12 plus 3. And when you simplify that out, that turns out to be 0. So we have a point negative 3 comma 0, and that's going to be on our graph right there. Okay, and I'll tell you this, I already know that this one's going to be 0 too, because I use this trick. If I go up and down the same distance from the vertex point here is at negative 2, then my y values will be the same. And just to prove that to you, let's actually find it. So negative 1 squared is 1, 4 times negative 1 is negative 4. And then we have that plus 3. When you add those together, again, you get 0. And that should always work. These should always be the same number as long as you're traveling up and down the same distance from the vertex. So there's our second point. Now we have 3 points, and that's all we need to connect the dots right there. Okay, we said that parabola should open up, and it does, like you can see right there. And the last thing we need to find is the y-intercept right here. And the y-intercept is easy to find. The y-intercept on a graph always occurs when x equals 0. So all we need to do is plug in, let me just extend this table, all we need to do is plug in 0. So 0 squared plus 4 times 0 plus 3, and that equals 3. And sure enough, this last number is always going to be the y-intercept when you write something in standard form. So let's put that up here, and actually if we extend that a little bit more accurately, okay, we don't want that coming off like that. Okay, but that's basically what the graph looks like. So again, the key step here is finding the vertex, and then once you have the vertex, you can easily find a lot of this other stuff. The other thing is to make a table of values, and you only really need 3 numbers. One should be the vertex point, which is negative 2, and then a number right before that and a number right after that. So what I want you to do is try and graph this one on your own using the same steps that we just did, and then check back for the answer in the next video.